right, today we're going to look at all the properties of quadrilaterals. Yesterday we defined, or in the previous section, we defined by definition these quadrilaterals, but now we're going to look more specifically at all the properties that each of these quadrilaterals have. So first of all, I'm going to, anything that relates to sides, I'm going to write in pink. Anything that relates to angles, I'm going to write in blue. And anything that relates to the diagonals, I'm going to write in purple. So a parallelogram, yesterday we said by definition, opposite sides parallel. And so we can mark that on our drawing like this, showing that the opposite sides are parallel. Now, in addition to that, opposite sides are also congruent. So I'm going to mark 2 and 1 to show that the opposite sides are congruent. Opposite angles are congruent. So this angle is congruent to this angle. Oops. And this angle is congruent to this angle. I'm going to skip ahead to pairs of consecutive angles are supplementary. So since we have parallel lines, these are same side interior situations. So we have angle A supplementary to angle R, angle A supplementary to angle P, angle P supplementary to angle L, and angle L supplementary to angle R. Finally, the diagonals bisect each other. So those pieces are congruent and these pieces are congruent. The diagonals themselves are not congruent. There's obviously one long and one short, but they bisect each other right here at that midpoint. Well, as we move on to other quadrilaterals, remember rectangles, rhombuses, and squares are all also parallelograms. So all properties of parallelograms apply to rectangles. So I'm going to mark opposite sides parallel. I'm going to mark opposite sides congruent. Now, opposite angles are still congruent and supplementary, but in a rectangle, remember, these are all right angles. So they still have the properties of the parallelogram, but they're more specifically all right angles. And then in this case, the diagonals still bisect each other, but the diagonals in a rectangle are congruent. I'm going to show that by drawing them in, and then all of these are equal then. Each of those pieces of the diagonal are congruent. Now, for the kite, kite is not a parallelogram, but we just defined the kite yesterday by the short sides being congruent and the long sides being congruent. Kites also have some other cool properties. Diagonals are perpendicular. So they do cross there at a 90-degree angle. Also, one diagonal is the perpendicular bisector of the other. So it's obviously not the long one, but the short one is cut into 2 equal pieces. And the diagonal, one diagonal, bisects a pair of opposite angles. I'm going to call that blue and purple because this diagonal right here bisects these angles. Now, they're not congruent just to each other, but those are bisected. And then here we have one pair of opposite angles congruent. So this angle right here is congruent to this angle there. So even though by definition we only had the 2 pairs of congruent sides, the shorts and the longs, there are a lot of cool properties with kites. Now for the rhombus, all properties of parallelograms apply. So opposite sides parallel, but remember for the rhombus, all sides are congruent. So all sides are going to get 1 mark. Also notice it says all properties of kites apply, which means that is a right angle. And because all properties of parallelograms apply, oops, you know what? I'm going to back up and do those in purple. So right angles, those are congruent. These are congruent. They bisect each other. We have, oh, and the diagonals bisect the angles. So all the angles, not just, nope, just the one pair, sorry. Just like in the kite. I was getting mixed up with the square. So, so we have these bisect. Actually, they bisect both. Let's mark those. Yes, because the diagonals are going to divide the rhombus into 4 congruent right triangles. And that's what we have there. You can see by all the angles marked, all the sides marked, the right angles. They are 4 congruent right triangles. Now the square is everything. We have all the properties of the rectangle and the rhombus. Remember, a square is a rectangle and a rhombus. So we have opposite sides parallel, all sides congruent. We have the right angle. Diagonals are congruent and bisect each other. Oh, and all these angles are congruent because they bisect the opposite angles. So what we have here are 4 isosceles right triangles. 45, 45, 90, 4 congruent isosceles right triangles is what it creates. Finally, we have the isosceles trapezoid. So by definition, we said these legs were congruent. By definition, these bases are parallel. Now, just like the isosceles triangle, these base angles are congruent. And because we have the parallel bases, same side interior makes these upper base angles congruent as well, since they have to be supplementary with the lower base angles. Diagonals are congruent. So I'm going to just draw those in to show it. They don't bisect each other, though, not like in a parallelogram. And like we said, any lower base angle is supplementary to its upper base angle. So angle P supplementary to angle T, and we have angle A supplementary to angle R. So there are all those properties, and those are things that you're going to be referring back to as needed, especially the 5 regarding the parallelogram. Those are probably the most important. All right, so this is point A. It got cut off there. So now we're going to do a couple proofs. We are given a parallelogram. So if you are given a parallelogram, you are basically given those 5 properties of the parallelogram. Now, as it says right here, the book usually just says this. So if they give you that notation, that means parallelogram ABCD. So we are given parallelogram ABCD. We are given angle GHA congruent to angle FEC. I'm going to mark those right now. So GHA, FEC, those are congruent. And we're given HB congruent to DE. So we're given HB this congruent to DE. All right, so looking ahead, we want to prove that GH is congruent to EF. So to do that, it would be really great if we And I'm gonna shade them in here. If we could show this triangle, like coloring in, is congruent to this triangle. If we could show those two triangles were congruent, then we would have those two sides congruent by CP/CTC. So let's see what we can do. Properties of parallelograms. So first of all, it would be really great if I could show EC was congruent to AH. Well, by properties of parallelograms, I know that this whole side is congruent to this whole side. And so if I have the full side minus the partial, that would give me the piece I want. So I'm going to start with DC congruent to AB. And that is because if you have a parallelogram, opposite sides congruent. So we can say that. And now that we have the opposite sides congruent, we can say EC congruent to AH, and that's because if the whole side, congruent segments, minus congruent segments, the pieces that were given, equal the piece left over, congruent segments. So it's like AB minus HB equals AH. All right, so let me mark those. We got those sides. We had, I'll mark them a little darker now since I colored it in. We have these angles that we were given. So we need something else. Well, if we have parallel sides, these two angles here would be alternate interior. So that's what we're going to do next. Before we can say that, though, we have to say that DC is parallel to AB. And we know that because if we have a parallelogram, opposite sides are parallel. And if those two sides are parallel, then we can say angle ECF is congruent to angle HAG because parallel lines mean alternate interior congruent. And now we have enough to say those triangles are congruent. So we can say triangle ECF congruent to triangle HAG by ASA. And then finally, we can say what we want to say, that is GH congruent to EF, and that is CP/CTC. So you can see how we still need to know all those angle relationships with parallel lines since we're going to be dealing with parallelograms. All right, one more proof. We are given parallelogram. In fact, that's all we're given is parallelogram ABCD. So parallelogram ABCD given. Now, we want to prove, and this is where it gets a little tricky, we want to prove that AC and BD bisect each other. So notice that's one of our 5 properties of parallelograms. So we can't just say, oh, it's true, done. No, we can't use this property to prove it, okay? So basically we have 4 things we can say about our parallelogram, just not that one. So if we want to prove that AC and BD bisect each other, we need to show that AE is congruent to EC and BE is congruent to DE, all right? So to do that, and since they have given us those certain angles marked, I'm going to highlight these. We're going to focus on these 2 triangles. Let's focus on those 2 triangles. So let's talk about some angles, right? Oh, and sides maybe. So it'd be really nice if, say, these 2 sides were congruent. Well, they are, because that's a property of a parallelogram. So we can say, whoa, I didn't mean to zoom in. We can say that AD is congruent to BC, and that's because if you have a parallelogram, opposite sides are congruent. But we need to say something about those angles too. And to get at those angles, just like the last problem, we need parallel lines. So we're going to say AD parallel to BC, because if you have a parallelogram, opposite sides are parallel. And once we say that, and we have these opposite sides parallel with either this transversal, 3 and 4 are congruent, or with this transversal, 1 and 2 are alternate interior angles. So I'm going to say angle 3 congruent to angle 4, and angle 1 congruent to angle 2. We can see them both because it's all the same reason. Parallel lines, alternate interior angles congruent. So I have 1 congruent to 2, 3 congruent to 4. Now that I have that, I can say triangle AED is congruent to triangle CEB, and that is by ASA. And now that I have that, now these corresponding parts are congruent. So I have this congruent to this, and that congruent to that. So I can say DE congruent to BE, and I can say AE congruent to CE, and that's all by CPCTC, which means finally AC and BD bisect each other. And basically it's if two segments divide each other into two congruent segments, then they are bisectors. Okay, basically when they intersect, they divide each other in half. And that's it. Good luck.